I'm here with you with your Chapter 1, Section 2 notes. So again, feel free to just watch all the way through if you think I've got this. Otherwise, I'd like you to go ahead and listen through each example and then maybe pause to copy down and make sure you understand exactly what's going on. We're going to look at functions, domain, and range. I could teach you, I think, something brand new called interval notation. But what we'll first do here is just a quick review of domain and range. So we've got two examples of four ordered pairs. It's just a relation. We don't even know if it's a function yet. So two different examples of ordered pairs. We can look at this as a list of ordered pairs, and when I list the ordered pairs, they're put in squiggly brackets. We can look at them as a mapping. I think I'm going to come back to the mapping. We can look at them as a graph, of course, where we graph each ordered pair as a point. And we can also list the elements of their domain and range. So since I just have a limited number of ordered pairs, I can list the domain elements, and here are some things you need to remember. When listing elements of a domain, you want to put them in squiggly brackets. You want to put commas between them. You want to have them in order from smallest to largest, and no repeats. So I know in that set of red ordered pairs up there, I think there were two ordered pairs that has 1 as an x coordinate. Notice I did not list that twice. So in order, no repeats, squiggly brackets. Domain is all your x values, range is all your y values. Now, going back to the mapping, you don't see this very often, but I really like them. I think they're so cool. Domain goes in one oval, range goes in another. Notice that I put them in order, smallest to largest, no repeats, just like I listed the domain. And then same, in order, smallest to largest, no repeats. So they obviously don't go together just basic straight across horizontally. So you need to draw an arrow and say that this x value goes with this y value, and so on. This one goes with this y value, and so on. In order, no repeats, and then an arrow pointing which y value corresponds to each x value. To test if it's a function in a mapping, it's really easy. Just make sure that each x has only one arrow leading away from it. Each x can only point to one y value. So this one is a function. This one, because of this x coordinate right here that points to two different y values, that one's not a function. Also, you know that you've got your vertical line test if you have a graph. So this isn't really long enough to cover the entire graph that's here, but if you imagine this extending and it being a complete vertical line, as I work my way from left to right, notice I'm not touching any part of the graph. I'm touching nothing, nothing, nothing. Here, my vertical line would touch this point. So since my vertical line only touches the graph once, I'm good. I'm not touching anything. Here I touch this one, nothing. Here I touch this one, nothing. This one, we're good. Up here, however, my vertical line is not hitting anything. Oh, I hit one point. I'm good. Nothing, nothing, nothing. Oh, look, here my vertical line hits my graph twice. It hits it on this point, and this point fails the vertical line test. And that's what it looks like with a set of ordered pairs. Now, let's look at some actual graphs of equations. So on this one, I'm going to do the vertical line test from left to right. I'm good, I'm good, I'm good. I'm even good right here when x is -3, but the moment I cross into this oval-looking thing, I fail the vertical line test. So that's a no. This one, yep, it's only touching once all the way through. That's a yes. This one, this one's kind of tricky. You gotta be careful. We're good here, we're good here. this is good because one of my points is closed and the other one is open. So when I'm lined up here, the only way this vertical line touches the graph is here. And then it jumps up and it's touching up here. And then yes, 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 yes. Good. That one is a function. All right. Now, what if you don't have a picture? What if you don't have the graph to look at? What if you just have an equation and you're asked, is it a function or not? Well, some of you, I'm guessing there are fewer than 10 people out there at this point watching this video from our pre-calc classes. I'm guessing there are fewer than 10 people that know what the graph of this looks like. But I bet there are at least a couple. So one, if you know what the graph looks like, you can visualize it. You can visualize doing your vertical line test, and you can say, nope, that fails, the vertical line test. But what if you don't know what the graph of that looks like? Then solve for y. So subtract 2 from both sides, square root both sides, and remember, when you square root both sides, you've got to do the positive root and the negative root. So here's what happens. Think about this. Plug in an x, like plug in 6. What y value does 6 give us as an x? Well, 6 minus 2 is 4. I plug in 6. When I do the positive root, I get positive 2 once I square root it. I can also plug in 6 and do the negative root, and I would get negative 2. So one x value can lead to 2 different y values, not a function. All right, function notation. This was probably introduced to you in Algebra 1. When you first saw it, some of you were a little hesitant and you're like, darn it, I was just getting used to equations. Now why did you have to go and make them all complicated? But once you got used to it, it's no big deal. I actually prefer function notation, but we're just replacing the y with f of x. The thing that I like about function notation is you can always see what you plugged in for x as well as what you got for y. Also, when I refer to a function, instead of calling it 6x minus 12, instead of saying that over and over and over again, I can just call it by its name, which is f. So if ever I would want to talk about this, I can just call it f. I don't have to say all that. Now, what I'm going to show you down here is how to evaluate a function at different places. So here's our function, 10 minus 3x squared, and its name is h. So instead of saying 10 minus 3x squared all the time throughout this problem, I'm just going to call it h. We want to plug 2 into our function h. We want to plug in negative 4, and then we want to plug in x minus 1. So I know that you should be super comfortable with substituting a number in for x. The important thing here is that I talk about how to show your work and how to express your answer. So here we go. Notice I copied my function h, except everywhere there was an x, I made it a 2. And then I evaluated the right-hand side. You can either do this in your head or on your calculator. It's fine. Notice how I write my answer. H of 2 is equal to negative 2. Back in Algebra 1, this would have been y equals negative 2. It's a y value, but here's what's cool about it. This is the y value that I got by plugging in this x value. That's why I like it. Is because I see the y value and I see the x value that went along with it. So this is what your answer should look like. Next one, find h of negative 4. Okay, I rewrote. So this is like the minimum amount of work that you should show. Show me that you're plugging in negative 4. And then from that point on, you can either do the math in your head or on your calculator. Doesn't matter. So notice I did this by steps. I didn't have to. I could have just typed it in my calculator. But when I choose to do it by steps, You don't need to rewrite this every single time on your paper. This side isn't changing. This side is. So we're just evaluating more, and then look, final answer, h of -4 equals -38. This is the y value that I got when I plugged in -4 for x. Then, lastly, you're going to plug in x minus 1. This is what it looks like when I plug in x minus 1. Then, you have to start to evaluate that. So, we've got subtraction, we've got multiplication, we've got exponents. You need to realize and remember that the exponents come first. So, you need to take this binomial, x minus 1, and you need to multiply it by itself. Now, here's what I would like for some of you to do. I would like for some of you to visualize x minus 1 times x minus 1. Foil it in your head. Collect like terms. And write this on your paper. So, copy, copy, copy. The only difference is, foiled this in my head, and now I have this in parentheses, because I went ahead and squared this. Now, some of you are like, oh, I cannot foil in my head. Can't do it. Then don't. Absolutely. Don't foil in your head. If you need to, come out here to the side of your paper, or on a scrap paper, or wherever, and write it out. This times itself. Do your first, outer, inner, last. And then bring it back into your problem that you're writing. Try foiling in your head. If it doesn't go well, write it down off to the side. Do it. Import it back into your work here. And then I distributed my -3, and I collected like terms. Look at my answer. H of x minus 1, I get an answer that looks like that. Again, feel free to pause and copy down if you need to. Now, this is where I think I get to show you something new. So, you all have had quite a bit of experience graphing things that look like this. So, looking at this, drawing the graph. You've also had experience looking at a graph, coming up with the inequality. And you know that when the point is filled in, it's got the equal underneath it. When it's open, it doesn't have the equal underneath it. Okay, so what I'm going to show you is another way to write this. Another way to express this, but in interval notation. So the first thing that I need to tell you, make sure you know, is when you see less than or equal to, greater than or equal to, you're going to want to use a bracket. But when you see just less than or just greater than, you're going to want to use a parenthesis. Okay, now let me kind of start in interval notation, and I'll explain the brackets and the parentheses as I go. So, interval notation, we're going to write, some of them kind of look like ordered pairs. We're going to write basically two numbers. You're going to give me, where does this shading, where does it start and where does it stop? So I look at the picture, I know the shading starts at 3, comma, stops at 8. Now, the 3's filled in, so you can either look at it as filled in, and let let me add that up here. There we go. So if it's a filled in point, you're going to use a bracket. If it's a open point, you're going to use parentheses. So since the 3 is filled in, since it's greater than or equal to 3, I'm going to put a bracket on the left side around the 3. Now, look at the 8. What's happening at the 8? Well, it's the equal to again. It's the filled in, so it needs a bracket around it. It's interval notation. So whatever our variable is in the problem, it could be x, it could be whatever. Whatever our variable is, we're talking about, for that variable, all numbers from 3 to 8 include the 3, include the 8. Let's do the next one. I think you're going to get the hang of it. Where does it start? Where does it stop? Well, it kind of starts at 3, sort of. So I'm going to write 3. And it stops at 8. Okay. Now, what's going on at the 3? Well, it's open. It's not equal to. So around the 3, I'm going to put a parenthesis. But the 8, however, look, the 8's filled in. Bracket around the 8. I think you can do the next one. Start at 3, stop at 8. Do not include the 3. See, do not include the 3. Do not include the 8. All right? Keep in mind, it's always, where does it start? Where does my shading start and where does it stop? So those are the numbers that I'm going to use. And we're always going to read left to right. So my smaller number always comes first. Now, for the next 2 problems, I kind of want you to picture a number line. So here's a number line. All right. Now, this one says all values greater than or equal to -4. So, where does the shading start? Where does the shading on this graph start? Well, the number it starts at is 4. Sorry, -4. That's where it starts. Do we include the -4? Yes, we do. So I'm going to go ahead and put a bracket around there. Whoa. Okay. Where does the shading stop? Well, it doesn't. It keeps going and going. So its shading starts here, and on my number line, it keeps going and going and going to 5 to 10 to 15 to 20 to 100, 1,000, 10 million, 8 billion, and so on. So you need to tell me how far out it goes. So you're going to tell me it just goes to infinity. Now, will the shading stop at infinity and there's going to be a closed circle at infinity? I don't think so, because I can always extend it just a little bit beyond that. And it's an even bigger infinity. So you can't use a bracket around infinity, because a bracket is saying stop there, fill it in. An open circle or an open parentheses means it just goes a little farther and 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 a little. Okay? So we're going to put a parenthesis around the infinity. Okay, last one. X is less than -1. Okay, so we've got to look left. Where does the shading start? Well, think about -1 is like right here-ish, and we've got all these negative numbers. Well, how far back did the shading start? As far back as you can go. So our shading began way, way, way out here at negative infinity, comma. Where does it stop? It stops at negative 1. What are you going to put around negative infinity? Always a parenthesis. What are you going to put around the negative 1? Look at the picture, or look at this, parenthesis. So interval notation, things to remember. Low number goes here, high number goes here. Where does it start? Where does it stop? Think about whether to use parentheses or brackets. Now, let me say one thing. This one especially, kind of this one especially, looks like an ordered pair. It looks like a point on a graph, 3 over 3 up 8 point. It does. It looks like an ordered pair. That's what you're used to. It's what you've been doing for years. It's not an ordered pair. It's a range of x values. This represents all the numbers starting at, not exactly 3, but about 3.0000001. All those numbers, all the way up through not quite 8, but 7.9999999. It represents all those numbers in between there. It's not an ordered pair. So you might be freaking out right now, like, are we never going to have ordered pairs anymore? How am I going to know the difference? How am I going to know if this is an interval? What's the difference between an interval and an ordered pair? It's all about the context of the problem. If you're graphing points and you see something that looks like this, it's a point. If you're asked to use interval notations, if we're talking about a range of numbers, interval notation, you're going to think of this as all numbers between 3 and 8. Don't include the 3, don't include the 8. Now, since I've shown you interval notation, I want to also show you how to write, how to identify domain and range using interval notation and with a graph, not just a list of ordered pairs. So for domain, I've kind of color-coded them. For domain, I want you to look left and right. Domain of your x values. Look left, look right. So see this oval? How far left does it go? It goes to negative 3. So this is basically where my graph starts. And then how far right does it go? Well, it goes to positive 3. Interval notation. Is the graph filled in at those locations? Well, yes, it's obviously filled in. If it wasn't filled in, here's how silly it would look. There would be open circles there. There's not open circles. It's filled in. So since it's filled in, you're going to use brackets. Range, I've kind of got it color-coded for you. How far up and down, how far above and below the x-axis does this graph go? Well, that's as far as it goes. But remember, low number first. So the lowest it goes is negative 1. The highest it goes is positive 1. The graph is filled in there, so I'm going to use brackets around them. Okay. For this one, it looked to me like the graph keeps going off of the grid there. So domain, I'm going to look left and look right. So look left. Keep looking. Keep looking. How far left does it go? Well, it doesn't stop. It just keeps going left and going left and going left and going left. So where does this graph start? It starts way out there at negative infinity. How far does it go? Look right. It keeps going right, keeps going right, keeps going right. So it's going to positive infinity. Always put parentheses around infinity. Range, again, kind of color-coded for you. Look up and down. How low does this graph go? Well, that's as low as it goes. What y value is that? That's 0. This This is as low as it goes. How high will it get? Well, keep following it, keep following it. It's going to keep going up and keep going up and keep going up and keep going up, so it's going to go to infinity. Bracket around the 0, it's filled in, otherwise it would look really silly. There'd be an open circle there. And then parentheses always go around infinity. All right. And last, we're gonna, this gets a little tricky. We're gonna do domain and range without a picture, without a graph. And we're gonna put it in interval notation. Okay. So, there are two things to watch out for. One is you cannot divide by 0. Kind of already talked about that. You cannot divide by 0 in math. Boom, you blow up. 2, the second thing you cannot do in math is you cannot square root a negative number. Now, I know, in Algebra 2, you all talked about imaginary numbers, and you found a way to square root negative numbers, and you would use an I, the little lowercase I for imaginary. However, what we're doing right now in this chapter, we're looking at real numbers, not imaginary. So forget about imaginary numbers for just a minute, and just think with me, okay, for now, in the real number system, it's not possible to square root a negative. You can do anything else besides those two things. So when looking at an equation, I'm going to ask you, look at the equation, what's the domain? You don't need a picture. Think about plugging in a number for x. When you plug in a number for x in this setup right here, are you ever going to divide by 0? Are you ever going to square root a negative? Well, no. There's no division in this problem. There is no radical in this problem. So what that means is you can plug in anything. Any number you want. Good, bad, ugly, negative, positive, radical. You can plug in any number pi. You can plug in pi. You have no restriction on what numbers you can plug in. So how do we say that? Well, you've heard before, my domain is all real numbers. I can plug in any real number that I want to. You've also seen it written with the funky capital R, all real numbers. Here's what it looks like in interval notation. I can plug in any number from negative infinity to positive infinity. Why? Because I never have to worry about dividing by 0. Right here. Don't have to worry about dividing by 0. Don't have to worry about square rooting a negative. Next one. What numbers can you plug in for x? Well, is there anything you have to worry about? Are you ever going to worry about dividing by 0? No, there's no division in this problem. What about a radical? No, you're never going to square root a negative. There's no root in this problem. You're good. You can plug in anything. My domain, negative infinity to positive infinity. Next one. Do you see division? No. Do you see a radical? No. You're good. You can plug in any real number. Hope that makes sense. Hope you can do problems like this super quickly. There's no trouble here. This is never gonna happen. This is never gonna happen. We're good. Okay, let's look at when you do run into a problem. So here's my function. It's named h. What is the domain for this? Like if I were looking at a picture, how far left would it go? How far right would it go? Would anything be excluded? Yeah, something would be excluded. So here's what we've got. Remember the two things you got to worry about. You can never divide by 0 and you can never square root a negative. Well, I don't have a radical in this problem, so I don't need to worry about the whole square rooting deal. But I do have a denominator. So I do have to worry about, let's let's use all x's so that we never have to do 2 divided by 0. I never want this red cloud to be 0, because 2 divided by 0 is going to give me a bad result. I don't want the red cloud to be 0. So here's what I'm going to ask you to do. When you've got this type of problem, you're asked to find a domain, you need to think, oh yeah, I can't divide by 0. I want you to take whatever is in the denominator. If it helps you, put a cloud around it. Whatever's in the denominator. And say that it cannot equal. You probably don't write this symbol very often, but I want you to write this symbol. Say the denominator cannot be 0. So here I go. Here's my denominator in the red cloud. I'm going to write my denominator cannot be 0. And then solve it. Add 8 to both sides. Bring that symbol down. X can't be 8. X can't be 8. What can it be? Anything besides 8. So, one way to write that is saying my domain is X can't be 8. However, the instructions way back up there said, write it as intervals. Well, that gets interesting. So go back up to the number line. Let's see, where was that number line? Here's that number line. Where would 8 be? 8 would be right about here-ish, maybe. This is what X can't be. What can X be? Well, X can be anything from way out there at negative infinity all the way. Where are you going to stop me? You're going to stop me at 8. Don't let X be 8. Well, what about all those numbers? So we're going to pick up where we leave off. We're going to do another interval. We're going to start it at 8, and we're going to go to infinity. Here's what it's going to look like. Okay, interval notation says, remember, the only number we have to exclude is 8. So it can be any number way back out there at negative infinity. You know what goes around it. Stop me at 8. Don't include it. I'll explain this in a minute. Pick up where you left off. Don't include it, though. Pick up where you left off and head that way toward positive infinity, and you know what goes around that. Now, for my class, I do not care what you put between these intervals. You can put a comma. You can leave it blank. You can put one interval on top of the other interval. I don't care how you write it, as long as you've got the 2 intervals. In my math lab, when you're doing your homework, it's going to want you to use the 2 symbols. It's also going to want you to do the union symbol in the middle. So it looks like a capital U, but it's a symbol, not a letter. So you can't like type the U there. You have to use a symbol like you would a parenthesis. It just means union, and it's just something kind of picky that my math lab likes to do to you. Again, for me, I don't care how you write it. When you're doing a test or quiz for me, you can write it any way you want. But to get the answer right in my math lab, you're going to have to use the U symbol. Okay. Next one, I'm going to go through this a little more quickly because I've already shown you how to do it. So the thing you have to worry about is dividing by 0. Here are the steps that I told you to do. I got a red cloud around my denominator. Write down my denominator, say that it can't be 0. Solve it. Make sure you carry down your symbol. Here's what, you know what? X can be anything except positive radical 7 and negative radical 7. Just 2 numbers. We've got to leave out 2 numbers. X can be anything else except those numbers. So, ready? For domain and interval notation, start at negative infinity. Where are you going to stop me? Well, the first place you're going to stop me is the negative version of that radical. So if you're kind of imagining a number line, we're starting at negative infinity, you're going to stop me at negative radical 7, like negative 2 point something. Stop me? Don't include it. This makes my math lab happy. Pick up where you left off. Don't include it. All right, so we picked up where we left off. This is like negative 2 point something. Finish out the negatives, hit 0, go through the positives. Where are you going to stop me? The positive root of that. Don't include it. Make my math lab happy. Pick up where you left off and head to infinity. Feel free to pause that, copy it, let it sink in. I'm going to move on to radicals. Remember, one of the things that you cannot do in the real number system, you can't square root a negative. So this red cloud right here cannot represent a negative number. So be careful what you plug in for x, so that when you do 2 times that number minus 5, you don't want to get a negative. All right? So what I'm going to have you do, the steps for this problem is, I want you to look at the contents of the radical. So everything that's in the radical, I want you to write the contents out and then say that it can't be negative. Now this is a little bit tricky. If it can't be negative, then it has to be positive, right? Contents have to be positive. What about 0? 0's okay. If I say it can't be negative, you've got 2 choices. It could be 0 or it could be positive. So I want you to write your contents have to be greater than or equal to 0. So here we go. Wrote the contents. Notice I didn't put the radical, I just want you to scoop out the contents, write them on your paper. Contents, greater than or equal to 0, solve it. You know how to solve it. This is what it looks like as an inequality. This is what it looks like in interval notation. Okay, this gets a little tricky. There's no division here. You don't have to worry about dividing by 0. You have to worry about square rooting a negative. So watch. Took out the contents, greater than or equal to 0. Solved it. Add x squared. I know a lot of you don't like having your x on the right side, so I just flipped mine around. Although watch, I was really careful. See how my symbol is pointing to the x squared? When I flipped it around just to make it look like the way I want it to look, my symbol is still pointing to the x squared. Okay, so now I have this written the way I want it. I'm going to square root both sides. I'm going to remember to use the positive root of 16 and the negative root of 16. This is where it gets tricky. When you write the positive root of 16, your symbol stays the same. Say it again. When you write the positive root of 16, your symbol stays the same. When you write on your paper the negative root of 16, remember that rule, like when you multiply or divide by a negative, you flip the symbol around? That's kind of what's happening here. Your symbol flips around. Only when you write the negative root, not the positive root. Positive root, symbol stays the same. When you write the negative root, your symbol flips around. Now, here's like my answer. All numbers less than or equal to 4. Think about what that could be. 4, 3, and 2, and 1, and 0, and so on. But wait. They also have to be greater than or equal to negative 4. So like negative 4, negative 3, negative 2, negative 1. So you can see how we're like boxing in the numbers we can use. So this is what your domain is going to look like in interval notation. Okay, last one, kind of a combination of the two. What if you've got division and a radical? Okay, well you can't divide by 0 and you can't square root a negative. So what you're going to have to do is, if your radical's in the denominator, don't let your denominator be 0. don't let your radical be negative. So you're going to take out the contents and don't do greater than or equal to 0. We don't want that 0 in there. Just say greater than 0. Okay? So because it's in a radical, we want it to be positive. Yes, yes, yes. Because it's in the denominator, we don't want it to be 0. We've got that covered. We didn't put the equal sign under there. So I take out my contents, just use the greater than, solve it, interval notation. If you need to pause that and think on it, copy it, go ahead. Next one. Radicals in the denominator. We can't divide by 0. We can't square root a negative. So I take out my contents and say my contents can't be 0 because that whole denominator thing. So, see, can't. They also have to be positive. All right, so we're going to solve it. Keep your symbol the same. Add 81. When you do the positive root and the negative root, remember what I just said. When you write the positive root, keep your symbol the same. When you write the negative root, flip your symbol around. Now we have numbers less than -9, but numbers greater than +9. So I think I have this. Let's see. Yeah, I think that's how this has got to work. So my domain is numbers less than -9. Okay, well, start back at negative infinity. Go and go and go. Where are you going to stop me? You're going to stop me at -9. Don't include it. Why not? Because you're not supposed to. Okay. So that takes care of that inequality. And then I can't use numbers between them. I have to start here and go to positive infinity. 0, like numbers between -9 and +9 are not allowed. Don't believe me? Try them. It's not going to work out well for you. Okay? So there's your domain and interval notation. Hope this helps. Let me or your teacher know if you have any questions.